Okay, we're continuing on this problem. I'm so sorry. Somebody tried to call this iPad. So at 3/4, we got negative 3.063, and at 2, we got 36. So now you can just look at the y values, and it will tell you what your absolute max and absolute min are. So your smallest y value is where your absolute min is. So an absolute min of negative 3.063 at x equals 3/4, and absolute max of 36 at x equals 2. So that's really what they're asking you for. They're asking you to find the absolute max and min, the absolute extrema on the given interval. So what did we do? We took the derivative, we set it equal to 0, and we found our critical points. And then we made a candidate's test chart with our endpoints of our interval and our critical points that were in between those two values. Okay, so now we're going to try the same thing on letter B. We've got g prime of x is equal to 1 minus 2 cosine x. We're going to set that equal to 0. I'm going to go ahead and move the negative 2 cosine x over. It becomes positive 2 cosine x equals 1, and then divide by 2 on both sides. So we're looking for the x's where the cosine of that value is 1/2. So we would be looking from 0 to 2 pi. So we're going to look in all 4 quadrants. We know that cosine is positive in the first quadrant and the fourth quadrant. Remember, all students take calculus, and so cosine is positive in that fourth quadrant. They're all positive in the first. So we're looking for the angle x such that the adjacent over the hypotenuse is 1/2. And so using our special right, our 30, 60, 90 special right, we can see that this is at a 60-degree angle, and 60 degrees written in radians is pi over 3. And so our x value, pi over 3, and then also this is going to be 60 degrees, but we're going to go all the way around to figure out which one that is in the fourth quadrant, and it would be, since 2 pi is the same thing as 6 pi over 3, it would be 1 away from 6 pi over 3, which would be 5 pi over 3. So these are your critical points. So now, since I drew that, I'm not going to have room to do my candidates test. Darn it. I probably should have drawn that over here. Well, I guess I'll erase it. Sorry about that. Hope you guys got it. First and fourth quadrants. And now, candidates test. We're going to draw a rectangle here. And we're going to list x and f of x, or actually g of x. Sorry, g of x for this one. And our endpoint, 0. We've got the next one would be pi over 3 is our critical point. Then we've got 5 pi over 3, and then we have our last endpoint of 2 pi. So now, if we look at our original function, remember this is our original function that we're talking about here, sorry, I was trying to fix that and it kind of erased everything. So if we look at g of x and we put 0 in, we get 0. And if we put pi over 3 in, well, go ahead and put it in your calculator. It's going to give us negative 0.685. Put that g of x in your calculator so you can get these values. 5 pi over 3 is going to give us 6.968. And at 2 pi, 6.283. And so now we are just looking at those values to decide what our extrema are. And you can see that your absolute lowest value, your absolute min of negative 0.685 occurs at x equals pi over 3. And your absolute max value of 6.968 occurs at x equals 5 pi over 3. And so those are your absolute extrema based on your candidates test, and your, how you found those critical points was using your derivative and setting it equal to 0. Okay? So now we'll go on to our next one, which is letter C. And again, we're looking at sine squared x minus cosine x, and we're going to take the derivative of it. So our h prime of x is going to equal, now remember, when you're looking at your h of x to take the derivative, it's going to be sine of x squared minus cosine x. So when you're doing that, you'll bring the 2 down, times sine of x to the 1, and then times the derivative of sine x. And then minus the derivative of cosine is negative sine, so that's going to be a positive sine. So we took the derivative of this sine squared x, and then we got 2 sine x cosine x, and we took the derivative of negative cosine, we got positive sine. So now this is our derivative, and I want to set it equal to 0. And when I look at this, I think, oh wait, there's a sine of x in both of these, and if I factor that out, I'm left with 2 cosine x plus 1. So now I can look at, what makes the sine of x 0, like where are the x values where the sine is 0 in our interval. Remember, we're looking at this interval. And then we're also going to look at what makes this 0. So we're looking at 2 cosine x equals negative 1. Where is the cosine x where the answer is for the cosine of for what x value is it? Negative 1/2. So for these, you're going to be looking in the second and third quadrants for the negative cosine. Again, all students take calculus, so you know that cosine is positive. They're all positive in the first, and cosine is positive in the fourth. That means cosine is negative in the second and third. So we're talking about a negative 1 here over 2, and we're looking for this reference angle. This is going to be a positive square root of 3. This is going to be a negative square root of 3. And so this is going to be pi over 3, but from here to here, we've got 2 pi over 3. So for this one, my x value is 2 pi over 3, and then this would be 3 pi over 3. This would be 4 pi over 3. So 2 pi over 3 and 4 pi over 3 are the two places where the cosine is negative 1/2. And then where is the sine 0? Including 0, right? So we've got it at 0, it is 0, and also at pi. So those are your two places. I didn't go to 2 pi because I'm only going from 0 to 3 pi over 2. But that leaves us with a total of one of your critical points is also your endpoint, okay? So if we don't count that one as a critical point in between, we've got 1, 2, 3 critical points in between. So using our candidates test, we're going to draw a rectangle. And of course, we've got x and we've got h of x. And so we're going to start with our endpoint, which is also a critical point. The next one, because I like to do these in order, like if we were on the number line, the next one would be 2 pi over 3, then pi, then 4 pi over 3, and then lastly, your 3 pi over 2, which is your endpoint. Okay, so now, again, you can pause and put this sine squared x minus cosine x into your calculator so that you can use your table on your calculator to find these values. And you can see at 0, you get -1. At 2 pi over 3, you should get 1.25. At pi, you should get 1. At 4 pi over 3, 1.25. And at 3 pi over 2, 1. And so now we just have to figure out, looking at these y values, what is your absolute max and what is your absolute min. So I always like to do the absolute min first. I don't know why, but absolute min of -1 at x equals 0. And then your absolute max is occurring in 2 different spots. So absolute max of 1.25 at x equals 2 pi over 3 and x equals 4 pi over 3. Okay, so it can happen in 2 spots, but really there's only one maximum. It's just that 1.25. It's just happening in 2 spots. So there are your extrema. And letter D, we've got f of x equals ln of x squared minus 9. So now, think about this before we go any further. I want you to think about, if you had this function, you know that this can't be 0, this whole thing here, because you can't take the natural log of 0, and it can't be negative. I'm going to say or negative, okay? So, you know, if x were 1, it'd be negative, so x can't be 1. If x were 2, it'd be negative. That argument would be negative, and that can't be, you know, so the argument, which is that whole thing here, this whole thing can't be 0, and it can't be negative. So we know that x squared minus 9 must be greater than 0. Okay, it has to be. It can't be negative, can't be 0. It has to be greater than 0. And so when we do that, when we're trying to figure out what this inequality is, this quadratic inequality, we pretend like this is an equal sign and we find critical points. So these are your critical points. And we say, okay, I know that everything we need lies either between these 2 values or it lies on the outskirts on the other side of these 2. Okay, so what you do once you've, decided that your critical points are -3 and +3, now we're just going to test. We're going to, put a 0 in and see if that's going to give us something good into our, you could put it into this one if you want to, go all the way back to that one, or you could, go back to this one. But if I put a 0 in here, 0 minus 9 is greater than or equal to 0. That gives me a false. That means it's not everything in between -3 and 3. But if I put a 4 into our test, and I say 4 squared minus 9 is greater than 0, well, that'd be 16 minus 9 is greater than 0, 7 is greater than 0. That would give me a true statement. So I know that we would have an open circle here and everything going this way. All those x values are going to work. And then you can try -4 test. And when you square -4, remember, when you're putting that in, it is in parentheses, like that. So that means -4 times -4 is +16. And so you again get a true statement. So for that test, it's also true. And so open circle and then everything going that way. So you can see that your domain for this function in letter D is -infinity to -3 union 3 to infinity. That is your domain. So you don't even have any type of a function in between -3 and 3. There's nothing there. So therefore, if I'm looking on the interval from -2 to 5, I know I have a huge problem. I do not have continuity there. This is not going to work. So for letter D, I'm going to say f of x. This is my answer to letter D. Sorry, I'm down here, but I kind of wrote everywhere else. So letter D, my answer would be f of x is not continuous on negative 2, 5, since the domain of f of x is undefined from negative 3 all the way to positive 3. So the extreme value theorem does not apply. And see, up here at the beginning, when we were looking at our instructions, it said find the absolute extremum of the function on the given interval provided the EVT is applicable. If it is not, justify why. So on letter D, that was the first one that we hit that was not, we were not able to use that extreme value theorem. All right, so now let's look at letter E. That one is a cube root, okay? And this one, when you think about a cube root, it doesn't matter if you have negatives under a cube root. So when you're looking at a cube root, you don't have to worry about like negatives underneath the root, because on cube roots it can be negative. And so I didn't have to worry about that. So let's go ahead and take the derivative. And actually, you'd be thinking of this as x minus 2 to the 2/3 power. So when I take the derivative, I'd bring the 2/3 down times x minus 2 to the 2/3 minus 3/3. So that would be to the negative 1/3, and then times the derivative of x minus 2. Well, that derivative's just 1. So you've got 2 over 3 times the cube root of x minus 2 would be your derivative. And you're looking to see where it would be 0 or where it would be undefined. Remember, way back, we haven't had to use where it's undefined because all the ones that we've had so far were all just defined everywhere, so we didn't have to worry about that. But on here, what makes your derivative 0 would be what would make your numerator 0, okay? And since 2 can never be 0, there is nothing, I should say nothing meaning no x value that makes h prime of x equal 0, okay? Because if there were, it would be what would make the numerator 0. And I know that's terrible handwriting, and I'm sorry. So there is nothing, and that means no x value that makes h prime of x equal 0. Looks terrible. Let's try that again. There is no x value that makes h prime of x equals 0, okay? Because if it were, it'd be in the numerator. So now we have to think about, okay, well, what about this denominator? What would give you 0 in the denominator? And hopefully you are looking at that and you're saying x equals 2, right? Because if this was the cube root of 0, if that was 2 minus 2, that would be the cube root of 0, which is 0 times 3 would be 0. So x equals 2 is the x value that makes h prime of x equal undefined, okay? So that's a critical point, because that is a point, or that is a critical value, because at x equals 2, your derivative would be undefined. So that's considered a critical point. So now what do? So candidates test. So we'll do this up here. Candidates test. And we'll make our little chart here. Hopefully I can fit everything in there. Here's our x and our h of x. And so now we've got our endpoint of 1. We've got our critical point that makes our derivative undefined at 2. And then we've got our endpoint at 10. Whew. Yep, my box was big enough. And so now you can put your h of x into your calculator, use your table. You can pause the video at this point so you can put your h of x values in for 1, 2, and 10. And you should have gotten 1 for 1, 0 for 2, and 4 for 10. And so now we can just look at those values and we can find our absolute extremum. And so we can say that there is an absolute min of 0 at x equals 2 and an absolute max of 4 at x equals 10. And these are your extrema for letter E. And that is it for our second lesson of Unit 5. Hopefully you guys are doing okay. Hopefully you're encouraging your friends to watch the videos. Not getting lots of views.